Some real life application with this problem. Number 6 says a chemist must mix a 10% alcohol solution and a 43% alcohol solution together to get 110 milliliter of 31% solution. How many milliliters of each solution should be mixed to get the desired solution? Well, it calls to making some tables and things like that, and writing a formula, make a math model. We are talking about mathematical model already. And then we also did, remember, conversion and things like that, from percent to decimal, decimal to percent. So all of those techniques come into play doing those kind of conversion. So let's go ahead and see how we should create a little model for this. Let's say we'll put our solution here. Alright, so we have our solution here, and that is in percent. And let's say we'll put our number of milliliter of alcohol here, and then we'll put our percentage of alcohol here, and then at the back here we'll put our amount in milliliter. So that's the amount of alcohol. Alright, so then let's go ahead and create a nice little chart, and we'll put here, because the problem says that a chemist must mix 10% of alcohol solution and a 43% of alcohol solution. So let's put the 10% here, and let's put the 43% here of solution. And by doing that, we want to get 110 milliliter of a 31% solution. 31%, and how many milliliter here? It says 110 milliliter. So this appears to be like what we'll be doing. Here we have in one column, we create a nice matrix here. This is a 4 by 3 matrix. We have 4 columns, 4 by 4. It's a square matrix. So we have there. Now, they want 110 milliliter of the solution. So we'll say that let the 10% be X amount, and let the 43% be Y amount, because we don't know that. We'll assign a variable. If you don't want to use X and Y, you can use some other A and B or something like that, or L and N. That doesn't change any answer. It's just, they are just placeholder. And then we know the percent of alcohol then here in decimal. In decimal is going to be 10% is going to be 0.10. 43% is going to be 0.43, and 31% is going to be 0.31 in decimal representation, because it's put there just for convenience to do your calculation. All right. Now the amount in each row, which we don't know, but we'll have to multiply the amount by this percent. So this is going to give us 0.10x of the 10% solution, and then we'll multiply 0.43 by y, 0.43 by y, and that will give us the 43% solution alcohol. And then when we add these two, we must get this amount here. When we add these two here, we must get 31%, which is 0.31, multiplied by this amount of alcohol. The amount is 110 milliliter. So if you do the multiplication there, use a little handheld calculator, and we'll see how much that is. 34.1. How much? 34.1. Yes, if you multiply 0.31, multiply by 110, thank you very much, 34.1. This gives us 34.1. Alright, so in this table here, we have all the data. We have all the data we need and information. All that is left now is for us to form two equations in two unknown. Here, if you look here, we have one already. We have that X milliliter plus Y is going to give us 110 milliliter of the alcohol solution. That's one of them. And then if you look at the amount, so we're going to be using the milliliter, and when you multiply with this to give us the amount of alcohol, of those percentages. We'll put that in another equation here. So we get 0.10x plus 0.43y is going to be equal to 34.1. That's our equation. So you see now, from the table, we are able to extract all those information and we get our two equations in two unknowns. This is a system of linear equation. That's what the type you are dealing with. But the one you are dealing with, you had integer coefficient. Here we don't have integer coefficient in the second one. That's what will make it a bit more complex, because integer coefficient is much easier. Now, how are we going to solve this? We can go ahead and use substitution. To use substitution, we can take equation 1 at the top there and solve for y. So y is going to be equal to 110 minus x. We solve for y, and now we'll use substitution. We'll substitute this y here for y in here, and we'll get an equation all in one variable. Are we on the same page, everybody? Anybody have any question why we are doing what we are doing? All right? Yeah.
I don't get what you y equal 100.
Oh, you don't know? How we get y equal to 110 minus x? Okay. What we are doing, we are taking one of the equations and we are solving in terms of one of the variables. So by doing that, we are able to substitute that into the other equation and eliminate one of the variables. If we know that y equals to 110 minus x, in the second equation, we can get rid of y by, instead of using y, we'll use 110 minus x. So what will happen here is that we are not going to have y in here anymore, because we'll have an equation all in x. But do you see how we get this? By taking the equation number 1, the one at the top, and we solve in terms of one of the variables. And I decide to use y. I could have used x, but I intend to use y. You can use any one you want. As I mentioned, there is more than one way to solve the problem. All right? If somebody said, well, there's no another way, that's fine. You sure do. There are other ways. Okay? You're welcome. And we are encouraging that, sure to participate, bring up some more ways and things like that. But this is one of the ways. All right? Now, let's go ahead and let's substitute that for y in here, and this is what we'll get. We have 0.10x plus 0.43 times 110 minus x equal to 34.1. So you see now, this one here, even though we have a little parentheses here, we don't have any more y in here. Everything is going to be in x. And that should simplify it quite greatly, because if we go ahead and use the distributive rule, which we know how to use, this is what we'll get. This will be 0.10x plus, if you multiply 43 by 110, you get 47.3, and 0.43 times x give us minus 0.43x equal to 34.1. So this is where we are now. Now what we can do is that we'll subtract this 47.3 from both sides. It means to say we're getting rid of the numerical part over here. We'll just keep all our x's over here. So if you do that, we will get, we subtract this from here, from both sides. Minus 47.3 minus 47.3. Alright, so that leaves us then with 0.1x minus 0.43x, and this will give us minus 0.33x equal to minus 13.2. Alright, how did we get minus 13.2? Because 4.1 minus 47.3 give us minus 13.2. Alright? Don't get mixed up with it. We're going it step by step. Over here, I don't have this 47 anymore, 0.3, because it has been cancelled off. All I'm left with is 0.10x minus 0.43x. Will give me minus 0.33x. Alright? Those are decimal numbers. It's remember, we are not working with nice number anymore. Integers, pretty nice to call and use. We are using these kind of decimal. Now, what's left for us to do here now is to divide both sides by minus 0.33. We'll divide both sides here by minus 0.33 and do the same thing here, minus 0.33. Our answer will come out in the positive because negative divided by negative will give us plus. And if you do that, we'll get x. We get x equal to 40. X equal to 40. Alright, and that means to say we'll be having 40 milliliter of 10% alcohol solution. This is 40 milliliter of the 10% alcohol solution. And then, if you get 40 milliliter, you subtract 40 milliliter from 110, and 110 minus 40 will give us 70 milliliter of the 43% alcohol solution. This is 70% of the 43% alcohol solution. So that's what we were required to find. What amount of the 43% alcohol solution, and how many milliliter of the 10% alcohol solution. And that's your answer. If you go back and check it, 40 plus 70 give us 110, which is the amount they wanted here. Alright? So, this is what we need. So then your mixture then would have 70 milliliter of 43% alcohol solution and 40 milliliter of 10% alcohol solution. That's what you will have in the mixture. Anybody have any question on this? I don't have much space to, to space it out, so that's why it look a bit jumbled up here. All right? So, we'll work some more of these problems here. Later on, you'll have some of this coming up on your test. So make sure you know how to make these tables. All right, these tables are very important to solve these problems. Any question? Anybody? All right. So this here gives you an idea of how these systems of equation can be applied to real-life problem, real phenomena, solving problems. So I don't want you to say, well, why are we doing these